drill pipe was clogged. The mud was not freely draining into the well. The crew attempted to pump a weighted slug of mud into the drill pipe to push the clogged mud out, but this was not successful. With the drill pipe plugged, the drilling crew had to trip wet, meaning mud was in the pipe sections being removed at the surface. The drilling crew used what is known as a mud bucket to collect the mud from the drill pipe, which they drained into the trip tank. But the trip tank was also used to pump mud into the well during tripping. So the trip tank volume started to fluctuate as mud was pumped out to the well and drained in from the drill pipe. The fluctuations confused crew members, and they did not realize that while the drill pipe was removed from the vertical section, the well gained another 23 barrels of gas. When the bottom hole assembly, which is equipment at the end of the drill pipe that includes the drill bit, was near the top of the well, the crew finally removed the plugged part of the drill pipe. For the next hour, they tried to clear the clog. But at that time, and during a subsequent shift change, the well was still flowing, gaining another 31 barrels of gas and pushing more mud into the trip tank. No one saw the gain. At 6:10 a.m., the crew lifted the bottom hole assembly out of the well and closed the blind rams on the blowout preventer. They prepared a new bottom hole assembly for testing. When it was ready, a drilling crew member checked a pressure gauge on the rig floor to see if it showed pressure in the well, a safety precaution used before opening the blowout preventer. The pressure gauge showed no pressure. But at 7:57 a.m., when the blind rams were reopened so the new bottom hole assembly could be lowered into the well, 5 barrels of mud surged to the mud pits. At that time, a crew member pulled away the steel plate that had been covering the hole in the rig floor over the well. He waved over another worker who saw mud bubbling in the well, a sign that there was a significant amount of gas in the mud. That worker later told the CSB that he does not know if the mud bubbling was communicated to the driller. Between 7:57 a.m. and 8:35 a.m., while the drilling crew was testing the new bottom hole assembly, the mud pits gained another 102 barrels of mud, a very large volume. This significant gain likely displayed on the driller's data screen, but the day shift driller also chose to turn off the alarm system, and it is unknown if the driller saw this dangerous gain. At 8:35, with testing complete, the bottom hole assembly was removed from the well, and the mud pits gained another 12 barrels of mud, for a total influx of 207 barrels of gas into the well from the start of the tripping operation. A crew member saw mud flowing up out of the open blowout preventer stack. The mud was shooting up steadily, getting closer to the rig floor. The crew member told the driller, and the driller responded, that he was going to close the blind rams, but he never made it. Seconds later, mud blew upwards out of the well in what is known as a blowout. 2 workers on the rig floor ran into the driller's cabin, where 3 other workers were already located. Gas and mud then ignited, causing a massive fire. All 5 people in the driller's cabin were killed. The blowout continued for hours until a well control services company was able to shut in the well around 4 p.m. During its investigation, the CSB found data indicating that on the evening prior to the blowout, the night shift driller turned off the entire alarm system. Data also indicates that the day shift driller briefly turned on the alarm system, but then quickly turned it off again on the day of the incident. Other than that short period, the alarm system was off for 14 hours, leading to the blowout.
We were not able to conclusively determine why the drillers turned the alarm system off. A possible reason why they did is that the alarms were perceived as a nuisance or an annoyance. In fact, we found that had the alarm system been on, most of the alarms that would have activated during the 14 hours leading up to the incident likely would have been irrelevant to detecting the problems in the well.
For an alarm system to be effective, it must be configured so that the driller only receives alerts to conditions that require attention. But the CSB found that Patterson did not develop guidance to help drillers set the alarm system for the various operations performed on the rig, such as drilling, tripping, and circulating. Instead, to manage the alarm rate, both drillers apparently elected to simply turn off the alarm system.
We concluded that what's called a state-based alarm strategy is one way to solve this issue. For example, on a drilling rig, there could be different active alarms for each operation, such as drilling, tripping, and circulating, so that alarms critical to a certain operation do not become a nuisance when operating in a different state where those alarms are not needed.
Although there is a large body of guidance and recommendations on the design of alarm systems for hazardous operations, none are specifically targeted for the drilling industry. As a result, the CSB made a recommendation to the American Petroleum Institute to develop a standard on alarm management, specifically for the drilling industry, that addresses drilling's unique dynamic environment and provides guidance on implementing a state-based alarm system for different operating modes.
When the blowout started, 2 crew members on the rig floor ran inside the driller's cabin. 3 other crew members were already in the driller's cabin, and all 5 workers were killed.
It is unknown how long the victims remained alive inside the driller's cabin, but they had no viable escape routes. There were 2 exit doors from the driller's cabin, but both of those exit doors were blocked by flames after the gas and mud ignited. The CSB concluded that had the fire rating of the driller's cabin been insured for a minimum time, with emergency escape options from the floor or from the back wall, there could have been a better chance for the workers inside to have survived this incident. Stan Christman is a drilling expert who consulted with the CSB on the prior trust investigation.
On a drilling rig, the operations are controlled from the driller's cabin by the key man, the driller. And he has a crew that works for him on the rig floor.